Hey there, and welcome. Have you ever just been stopped in your tracks by a rainbow after a storm? It's one of those things, one of nature's most beautiful and fleeting shows. But here's the thing, it's not magic, it's pure physics. And today, we are going to break down the brilliant science behind how a simple rain shower can paint an absolute masterpiece across the sky.
It all starts with just a moment of pure curiosity. It's a question any of us could ask, right? You see the rain, you see the sun, and then bam, there are these colors where there were none before. That simple question is exactly what we're here to answer.
So that's exactly what we're going to do in this explainer. We're going to follow one single beam of sunlight on this incredible journey it takes through a raindrop to understand exactly how this spectacular arc of color is born.
Okay, so the first piece of this puzzle, while it isn't actually in the rain, it's in the light itself. We really need to get what sunlight is before we can understand how it gets transformed.
So that light traveling, 93 million miles from the sun? To us, it just looks white, maybe a little yellow. But that is a really clever illusion, because in reality, that one single beam of white light is actually a blend, a perfect mix of all the colors of the rainbow, all just traveling together.
All right, so we've got our beam of light, which we now know is packed with color. Now, let's grade in our second key player, one single, tiny, spherical raindrop just hanging out in the air after a storm.
So when that sunbeam hits the raindrop, it doesn't just, pass straight through. Oh no, a little three-step dance begins. First up, the light ray actually bends as it enters the water. That's called refraction. Then, it bounces off the inside back wall of the raindrop. That's internal reflection. But it's that third step, dispersion. That's where the real magic happens.
Dispersion. Now that is the scientific term for the real star of our show today. It's the process of splitting that seemingly white light into all of its secret parts. Let's put it this way, no dispersion, no rainbow. Simple as that.
So how does this whole dispersion thing actually work? Well, as that light enters and then leaves the raindrop, it bends. But here is the absolute key. Not all colors bend by the exact same amount. Violet light, it bends the most. Red light, it bends the least. And that tiny, tiny difference in the angle is all it takes to literally pull the colors apart from each other.
And that separation, well, that's what creates the iconic pattern we all know and love. The colors come out of that raindrop in a super precise order, from violet on the inside of the arc to red on the outside. You probably remember this acronym from school, right? VibGyor. This is the spectrum of visible light, unblended and on full display. Okay, so that was pretty cool, right? That's the whole journey through just one single raindrop. But hang on, a single raindrop is microscopic. So how in the world do we get from that tiny event to the massive arc that can stretch for miles across the horizon?
Well, that whole process we just talked about, refraction, reflection, dispersion, it's happening in every single raindrop that the sunlight passes through. Every single one of them acts like its own little prism, taking in white light and shooting out a perfect spectrum of color.
And look, we're not just talking about a few dozen raindrops here. We're talking about millions of them, all playing their part in that giant sheet of falling rain. This is so important. The rainbow you see isn't a single thing in a single spot. It's more like a collective illusion, right? It's the combined light from millions of those raindrops, with each one splitting the sunlight and sending a very specific color back to your eye at the absolute perfect angle.
So really, the whole takeaway, the crucial point, is this. If you want to get your head around a rainbow, just picture the sky filled with millions and millions of tiny, perfect little glass prisms. Each one is catching the sunlight, breaking it apart, and together, all of their combined light creates that stunning, colorful arc that just makes us all stop and stare.
And there you have it. That's the science of a rainbow. It's just such a beautiful reminder that something we might see as simple, a beam of light or a single drop of rain, is often packed with incredible complexity. It really makes you wonder, doesn't it? What other bits of everyday magic are just hidden in plain sight, just waiting for us to look a little closer?